Yeah. Question 21, assignment entropy, MCQs. Which of the following is a true for exothermic reaction shown below? You can also use a chat, you can use your mic to answer, and I will discuss. So when we check the options, which of the following is true for exothermic reaction? Exothermic reaction, what is the enthalpy change? Enthalpy change will be negative. So means A is totally wrong. Then because exothermic reactions are spontaneous reaction, and for spontaneous reaction, the total entropy must be positive. So the total entropy must be positive. So this is also wrong. It's written negative because for exothermic reactions which are spontaneous means happen by itself. So the total entropy must be positive. Then what about the entropy of the surrounding? The entropy of the surrounding is given by a formula minus delta H. Minus is a part of the formula, okay? So it's given by a formula minus delta H by T. And because it's an exothermic reaction, so delta H will be negative. So negative will be positive. So means the entropy of the surrounding will be positive. That's why B is the right answer. And entropy of the system should also be positive because as you can see, the gas is produced from aqueous and solid, a gas is produced, so entropy should increase. Is it clear? Question 21.
Yes, sir.
Question 22. Question 22, a decrease in entropy of a system occur, like entropy of a system is decreasing. Which change will decrease the entropy of the system? So entropy increases with temperature. So if you see, we are decreasing a temperature, so water freezes, that's why the entropy will decrease. Rest all of the remaining reaction for exothermic. Next is yes. The reaction below is carried out at 25 degrees centigrade. Use the equation and the data to answer the question that follows. Sulfur dioxide react with hydrogen sulfide to give sulfur and water. And standard molar entropies are given. What is the entropy of a system? How we work out the entropy of a system? How we work out the entropy?
Use the model entropy, like the entropy of the reactant and the product.
So it's positive enthalpy over temperature?
No, that is for entropy of surrounding. Just I will learn. So it is a product minus a reactant. Product minus reactant. So we'll just use a product because we just need a standard entropy change of a system. We don't need total. Even we can work out total, but we don't need total. We just need for system. So it is a product minus reactant. So sulfur dioxide, sulfur is a product. So this will be multiplied by 3. Like example, it will be 32 times 3 because 3 moles of sulfur plus 2 moles of water are there. So 2 times 189 minus the sulfur dioxide is 248 plus hydrogen sulfide is 206, but there are 2 moles. So 2 multiplied by 206 plus sorry, that's it. So just substitute the values, we'll get the molar and
-6.
what's the final answer?
Yeah.
2 186.
Yeah.
Okay, so A will be the right answer. So when we solve, A will be the right answer. The next part, actually, they asked entropy of the system, I guess. Yeah. Now, standard entropy change of, surrounding they ask. So if they ask for surrounding, how to work out the surrounding for entropy change of a surrounding? The entropy change of a surrounding is minus delta H by T.
107. So it's all
So minus, what is delta H? It is minus 107.4.
no, that was 2003.
But that is in kilojoule. We have to convert into joule.
You can do that.
So, and at what temperature it is done? At 25, so 298. And then it should be divided by 1000 to convert. Sorry, it was in kilojoule. Yeah, we are going to convert into joules. So divided by 298, like either C can be an answer or D, and then multiply, not because it is kilojoule, we want to convert into joules. So multiply by 1000. If it was in joule, usually it is in kilojoule, so multiply by 1000. And
It's
we'll get a positive answer, so it matches with option C. See, negative will be positive.
Yes,
yeah.
okay, okay.
Question 24. Calcium carbonate decompose at high temperature. So, and it is thermodynamically stable, okay? Endothermic reaction, reactants are thermodynamically stable. Why we call them as a thermodynamic stable? Why a substance is known as a thermodynamic stable? What it is having? Enthalpy change is positive. Look, this is
Because the activation energy is very high here. The greater difference between activation energy.
it have an enthalpy change which is positive.
so enthalpy, because it's an endothermic reaction or enthalpy change positive, they are thermodynamically stable. High activation energy is not the criteria. High activation energy, it is not like showing the thermodynamic stability. Same thing, entropy change of a system is positive. Here, yes, entropy change of a system is positive, but that is not the reason for that. Even this state, but these statements are correct, but they are not related to thermodynamic stability. Thermodynamic stability is always refers to endothermic reaction. So that should be positive. Yeah. Question 25, 2-methyl propane has a smaller standard molar entropy than butane. The best explanation for 2-methyl propane has why it is having a lower molar entropy. 2-methyl propane will be like this, the structure of a 2-methyl propane. This will be CH3. This will be H. This will be CH3.
Fewer ways of distributing energy quanta.
No, the boiling temperature will be different because branches have low boiling point. It's not about boiling point, like it's about entropy. Entropy depends on energy distribution as well as the number of particles.
To see, I think.
Fewer ways are there, that's right. There are fewer ways for distribution of energy.
Sir, but how? But how can we determine that?
Because what will happen as the branches increase, the distribution of the energy, the possibility of distribution of energy decreases. Like, For example, this is just an example. When it's a branch one, the center which is attached with different branches must have some energy to hold the branches. But here at the end, like example, if I say 10 joule of energy is there, so this might have 3 joules of energy, this might have 3 joules of energy, this might have 4 joules of energy, and this might have 0 joules of energy. Means in a straight chain, one of the group of the molecule may have 0 joules of energy. But in a branch one, the center one cannot have a 0 joule of energy, otherwise it will not support the structure. That's why we say fewer ways of distribution of energy. Like this is restricted, like this will have a certain fixed energy. It cannot be 0. So the distribution of the energy
Got it.
has changed. Clear?
Yes, sir.
So fewer ways are there for distribution of energy. That's why it is having a lower standard entropy. Which of the following is the correct order of increasing the entropy under standard condition? Oxygen, water, copper. The highest should be copper is solid. Copper is solid at room temperature. Like just check the state. Copper is solid at room temperature, water is liquid, and oxygen is a gas. First, you give a priority to the states. Then, if the states are same, then you give the priority to the number of the particles. Okay. But first priority is the states, then the number of particles. Enthalpy change of a sodium chloride, enthalpy of hydration of chlorine, lattice energy of sodium chloride and magnesium chloride, all are shown. Use the data to calculate the enthalpy of hydration of a sodium. How we can work out the enthalpy of hydration of the sodium? Look, remember this formula, enthalpy change of a solution is equals to hydration minus lattice. Okay, that's a formula. So enthalpy change of a solution is given 4. Hydration of a sodium is unknown, X, and it's a 1 mole, so we just write X. If it was 2 moles, we write 2X. Huh? Like example, if Na2O was there, we write 2X. And for chlorine, it is minus 364. And then the lattice energy is minus 780. Just simplify. Like 4 will be 4 plus, because this plus minus minus, other side will become plus 364. Minus minus is plus, other side will become minus 380. That will be X. So what's the answer? 420, how it should be? This is 780 and this is 364 and 4. So 368 minus 780, it should be in 12.
Negative 412.
Negative 412, not 420. Because the number, if to be a 0, that it should have a whole number. Magnesium chloride has more exothermic, like why magnesium chloride is having a high lattice energy than sodium chloride? Because magnesium ions are smaller and they have a greater charge density. So the size, as I mentioned, lattice energy depends on the size of the ion. So if the size of the ion is smaller, the lattice energy will be greater. So it is having a greater charge and smaller size. So it will, that's why it is having a greater lattice energy. Which reaction has an enthalpy change equal to enthalpy change of a solution? The term enthalpy change of a solution means when ions in the gaseous state, enthalpy change of a solution means when 1 mole of a substance is dissolved and it will form ions. So here 1 mole in 2 mole, when excess of a water is there, when a solid, because when ions in the gaseous state, like we have, if ions in a gaseous state will form a compound, we call that as a lattice energy.
Yeah.
When
Sir, for solution,
the term
solid should be
hydration is, the term hydration means when ions in the gaseous state become aqueous. We call hydration energy. Yes,
yeah.
you're saying?
I was saying that for solution, the enthalpy of solution, it should be from solid to aqueous, right?
Yes, solid to aqueous. Here, what is this? Gas to aqueous, it means it's a hydration.
This is hydration. Yeah,
Option B is a
hydration.
hydration, option B is a enthalpy of solution.
So both of them are gases, that will be the.
Enthalpy hydration energy.
No,
if-
both are gases.
If two ions are gaseous state,
Uh-huh.
so like substance is a gaseous state and dissolve, no, it will dissolve, we call hydration energy. When atoms in the gaseous state form ions in aqueous state, we call hydration. When atom in gaseous state form a compound, we call lattice energy.
Okay. Okay.
When element form a compound, we call formation. Question 29, ionic solid dissolve in water. Which of the following is about these standard enthalpy change is possible? Ionic compound dissolve. So, and for a substance to be soluble, enthalpy change of a solution should be negative.
Yeah.
And what about the hydration energy? Ionic dissolve, which of the following about the sign of these standard changes is possible? Like, we just need the sign. Like, if enthalpy change of a solution is there, it is a hydration minus lattice, okay? See, if a hydration is negative and the lattice energy is positive, this will give a negative answer always.
How
Hmm?
the
The thing is, hydration energy is always negative. Lattice energy is always negative. Both are negative. So means the option in which both are negative is only B. Clear?
in the case of the hydration energy.
Hydration and lattice to be positive. Enthalpy of solution can be any number, but the enthalpy of a solution, lattice energy cannot be positive. Lattice energy is always exothermic. And enthalpy of solution, but when both are negative, this enthalpy of the solution can be negative, can be positive. Because it depends on hydration. If hydration is more and lattice is less, it will be negative. If a hydration is less and lattice is more, it will be positive. And for a substance, usually when a substance dissolves, the enthalpy of a solution should be negative, usually. But here, some cases, we may get a positive answer. When it is a very slightly soluble or sparingly soluble, we get a positive answer. Is it clear? So for dissolving, enthalpy of solution should be negative because the hydration value should be more and lattice should be less. But because with reference to the question, some cases it can be positive, the lattice is higher and the hydration is less. And how we provide that additional energy by stirring. Like some salt, like example, when I add salt to water, it will not dissolve by itself. I have to stir. That stirring is providing an additional energy which we need.
So we can allow the one to
Spread. Question 30, which process produces a decrease in entropy?
Sir, one question. The hydration energy is also always negative, right?
Always negative, lattice is always negative. So look, enthalpy of the solution is a hydration minus lattice, okay? And both
Oh,
of
yeah.
them are negative.
Yeah, so double negative signs. Yeah, I got it.
So this will be negative, like say -3, and this is minus, and say this is -4. So what we get -3 plus 4, so we got +4 answer. Oh, sorry, 1 + 1 answer. So enthalpy of solution can be positive, can be negative. But usually when the enthalpy of solution is positive, substance does not dissolve. Why? Because the lattice is more and hydration is less. If the enthalpy of solution is negative, substance readily dissolve because the hydration should be more than the lattice to dissolve by itself. But like example, for a dissolving sodium chloride in water, the enthalpy of the solution is +8. So from where this additional energy we get it by stirring. That's why when you add salt to water, it will not dissolve by itself. You have to stir. Is it clear?
Yes, sir, clear.
Which process produces a decrease in entropy of the system? Which one? Then either the number of moles should decrease. Here, solid, aqueous, so this is increase. Solid, liquid, increase. Gas, and gas, but the moles are changing. Here, 3 moles, 2 moles.
Yeah.
This is a decrease. So C will be the right answer. So these are the MCQs of entropy. Next session, we'll do another topic like structure question as well and the KC questions as well.